I'm going to work through the answers here to the Stoichiometry intro worksheet. So starting off, just naming some substances, so that's one skill. And we can see, though, this is an ionic compound, and it starts with potassium. And we can see that this is the chlorate ion, so this is potassium chlorate. Now the next one's also ionic, okay, and that's potassium chloride. And the last one, the O2, that's just elemental oxygen. So find the mass of each of these. Okay, so for this we need our periodic table. But I'm going to go ahead and do my notes down here. I have a K, I have a Cl, and I have O times 3. Okay, I know that my potassium is 39.1. And my chlorine is 35.45. And my oxygen is 16, and I have 3 of them, so 3 times 16.00. So this bottom number is going to be 48. And I have 35.45. And 39.10. And I want to add all these up. I get 122.55. And that's going to be grams per mole. And I'm going to use that as a conversion factor. Okay, for my potassium chloride, then I'm just going to use these two that I have right here. So it's going to be 39.10 and 35.45. And then when I add those two up, I get 74.55. And again, that's going to be grams per mole. And all this information here is coming from the periodic table. Okay, oxygen, we have 2 times 16.00. So you can see that that's going to be 32.00. And again, that'll be grams per mole. Okay, so I have my molar masses. I need those because those are going to be conversion factors for me during my problems. Okay, let's go back here. So it says, number 3, given 0.58 mole sample of oxygen, okay, find the mass of the sample, find the volume of the sample, and find the number of molecules in this sample. Okay, so the mass, okay, I want to go from moles to mass. Now, if you remember way back, we had a chart where if I had moles, then I could go from moles to mass, and that would take one conversion factor. I could also go from moles to molecules and moles to liters, and I would use 6.02 times 10 to the 23 or 22.4 liters per mole, that kind of a thing. Okay, so we're still working with those kind of ideas. Let's go back. So find the mass of the sample. So I'm starting off with my given number here. So I have 0.58 moles of O2. And if I want to go from moles to grams, we can see on our map that only took one conversion factor. So 1 mole of O2, how many grams? We decided that was 32.00 grams of O2. So my moles drop out. And I have 0.58 times 32, which comes out to be 18.56. And my moles dropped out. The only unit I have left is grams, or I could say grams of O2. And that's my first problem. Now, if I want to go to volume, okay, volume means liters, okay, and I know that I can use 22.4 liters per mole. It's going to take one conversion factor. So let's go back and do it. And so I have, again, start the same way, 0.58 moles of O2. Okay, but this time the conversion I'm going to use is that there were 22.4 liters of O2 in 1 mole of O2. And I keep calling that my beach ball number because we have that constant, displayed in the classroom on a big beach ball. So when I do 0.58 times 22.4, 12.99 liters of O2. And that's my second problem. Now the number of molecules, okay, go back here again, I can go from moles to molecules, and we can see that that is going to be a one conversion factor problem. So let's go back and do it. So again, I start the same way, 0.58 moles of O2. But this time my third conversion is the fact that, I can take 1 mole of O2, 1 mole of anything, and that's 6.02 times 10 to the 23 as Avogadro's number. And again, that comes out to be 3.49 times 10 to the 23 molecules. Of O2. So the point here is we're working with those conversions that we used to do. Okay, and so we can go from moles to grams, we can go from moles to liters, we can go from moles to molecules using those 3 different conversion factors. So the molar mass we can use, or 22.4, or 6.02 times 10 to the 23. Okay, so now to the kind of new stoichiometry one to where we're going to go from one chemical to another. But first we have to go back and say, well, we want to identify this type of reaction. Well, this type of reaction looks like one thing on the left turning into 2 things on the right. So hopefully we'll say, okay, obviously that is a decomposition reaction. And what I'm going to do now is I have to balance. Now I have to pick any one element I want to start with the balance, and I could pick my K's and I could pick my CL's, but I'm going to pick my O's, and the reason is that there are 3 O's on this side and 2 O's on that side, so that's going to be a little bit trickier to balance. I'm going to get that to balance first, and everything else will fall into place. So if I have a 3 and a 2, I can balance that by putting a 2 here, and by putting a 3 here. And now I have 6 O's on both sides, so that part's balanced. Now I can do the K's or the CL's. I have 2 K's on the left, so I'm going to need to have 2 K's here. And the same thing, 2 CL's, 2 CL's, so I know that's a balanced equation. Now the big thing is that 2 to 2 to 3 ratio, that is the new piece of our stoichiometry problem. Okay, because the idea is I can start from moles of one chemical and go to moles of another chemical by using the mole ratio from the balanced equation. So I have all these other conversions. I can go from grams to moles, I can go molecules to moles, liters to moles, but the new one is the moles to moles conversion. So let's use that a couple times. First off here, so 5, how many moles of KClO3 are required to produce 0.58 moles of O2? So I'm just going to go from moles of one chemical to moles of another chemical. So that's going to take one conversion factor. And the given and desired, this is to look at the problem and kind of decide where am I starting. I'm starting with the 0.58 moles of O2. And it's important that I put down the unit and the chemical. And desired, what am I looking for? I'm looking for moles. How many moles? So I'm trying to find moles. And this time I'm trying to find moles of KClO3. and that's important. So that means when I do this, I'm going to be using the number for the O2, I'm going to be using the 3, and I'm going to be using the 2 as conversion factors. So now I just put in my answer, so I have 0.58, and my units are important, so moles of O2. And now that I'm at moles, I'm at the point here where I'm going to do my mole-to-mole conversion. So I'm just going to do, for every mole of O2, there are going to be a certain number of moles of KClO3. And I'm not, putting in ones, I'm putting in numbers that come from the balanced equation. So for O2, I want to use the 3. So 3 moles of O2 are linked to 2 moles of KClO3. Now when I go ahead and work out that answer, then it's pretty obvious. It's 0.58 times 2 divided by 3. So I'm going to get 0.39 moles of KClO3. And in fact, that is my answer. I could have written it over there. Okay, so 0.39 moles of KClO3. That's okay. Okay, same way over here. I have moles, and I'm going to moles. So again, it's going to be one conversion. Okay, what am I given? I'm given the 0.88 moles of KCl this time. So KCl, I'm going to use that number, the number 2. And I'm trying to get to moles of O2, so I'm going to use the 2 and the 3. So I'm looking for moles of O2. So 0.88 moles of KCl. And so again, I want to go moles of KCl. As soon as I get to moles, and I know I'm going to do a mole-mole conversion. Okay, KCl and O2. And back in the balanced equation, the O2 is 3. 3 moles of O2 for every 2 moles of KCl. And again, I'm using these two values right here, 2 and 3. And now what to do is just to solve the problem. So 0.88 times 3 divided by 2 comes out to be 1.32 moles. And that's moles of O2 because moles of KCl have canceled out. So that's my answer, 1.32 moles of O2. Now I'm going to do the same sort of thing. Okay, this is a little bit more complicated problem now, so number 7. So what is the mass of KCl? That's important. When 55.1 grams of KClO3 reacts. So I'm going to start with grams, and then I want to end up with grams, because mass means grams. And so I'm going to go grams to moles, okay, moles to moles, and moles back to grams. And that is going to be a, you can see it's going to be a 3 conversion factor problem to get this to happen. So let me clean up my map. And so I'm given 55.1, and that's going to be grams of KClO3. Okay, so I'm going to need the mass of KClO3, and we have that written above. And what am I looking for? I'm looking for mass, and again, mass means grams. So I'm trying to figure out how many grams, and this kind is KCl. So I'm going to be using my molar masses from way up here. I'm going to be using the molar mass of KCl. And I'm going to be using the molar mass of KClO3. And I'm going to be using the value here from KCl, the 2, and the 2 from KClO3. So that's how I'll set up my problem. So I have this already written out. So I write down my given value, 55.1 grams of KClO3, and then I have the conversion factor from above, so I'm going from moles of KClO3 to grams of KClO3, grams to moles, and then I'm going to do my mole-mole ratio, and we saw it in the balanced equation, it was 2 and 2, and then finally I'm going to go from moles back to grams. I use the molar mass of KCl. So I have a molar mass, I have a mole-mole, and then I have a molar mass. And so my grams of KClO3 drop out, moles of KClO3 drop out, moles of KCl drop out. So when I do all the numbers, I get 33.5 grams. And that is grams of KCl. Now in these problems, and it is important that we put in the chemical because we started talking about KClO3 and then we end up talking about KCl. So grams of what chemical makes a difference now. Okay, the last one down here is we have a problem, what mass of KClO3. So we are looking for grams, and grams in this case is of KClO3. Starting with liters, 15.6 liters of O2 gas. Now the fact we're doing liters means we're probably going to use 22.4 liters per mole to get our answer. Okay, so we have our given, we have our desired. We're going to start with the 15.6 liters, and I have this one written out as well. And we can see we start with the 15.6 liters of O2. Then we're going to use our 22.4 liters per mole. And once we get to moles, we do the ratio from the balanced equation. So there were 3 moles of O2 for every 2 moles of KClO3. And then we can go from moles of KClO3 to grams of KClO3 using the molar mass. And we end up with our answer. And the answer here is 56.9. And that is grams of KClO3. And that is how we do these kind of problems. That's the intro.